Hey, last section of chapter 6, separation of variables. So separation of variables is a method that we use, and its purpose is so many differential equations, when you go to solve them, you can't integrate them right away because the information's not in the correct spot to be able to do that. So we really only know how to integrate with one variable. And so a lot of times what we have to do is rearrange the equations so the variables are grouped together to be able to integrate, because that's how you solve a differential equation. So here I've got the first example written down right there. So let's say we have x squared plus 3y dy dx equals 0. And our goal is to solve this. Well, the way we have to do it is integrate. And I mean, just right off the bat, it kind of looks like we can immediately move x squared over. Well, and honestly, you could have chosen to move the 3y dy dx to the other side too. It really didn't matter which side you chose. I usually just keep the y's on the left because not a habit, but it doesn't matter. But if I go to integrate both sides, technically it's not going to work yet because I've got a dx being divided right here. So I need to have this dx be on the right-hand side with the negative x squared. And I'm going to multiply both sides by dx. Now, just that one kind of little step immediately has all of my information grouped together correctly, like variables. So this is called separation of variables. And on the AP test, it's usually traditionally a big deal. Most free response questions that involve separation of variables, they traditionally will give you a point just for recognizing that you need to move the information around. So even if you don't know how to finish this problem, as long as you recognize how it's set up, you can get points. But I want to finish this problem, so I need to solve it by integrating. So I'm going to integrate both sides. If I integrate 3y dy, I get 3y squared divided by 2 plus c, but I'm not going to put that because the other side has plus c. So I'll just do 1 plus c. Negative x squared, if I add 1 to that power, I would get cubed divided by 3. I'll just put the plus c over here. And now we can leave it like this if we want. So this is kind of one acceptable answer for a general solution. The rule of thumb essentially is that if you can solve it for one of the variables, you do. But if, like say in this case, we couldn't solve it for y, because during the process we would have a plus or a minus. So traditionally, you don't solve it for y if you would have to write the other side of the equation split into two equations, like a plus or minus. So on this one, this is one acceptable answer, and we would leave it there. If the 3/2 bothered you, you could multiply both sides by 2/3, and you could write it as y squared equals, what would we get? We would get negative 2/9 x cubed plus c. And it would still be just a regular c, because if I multiply c by 2/3, then 2/3 c just turns into c. So then this would be another acceptable, general solution. And honestly, I mean, they're both correct, so it's not like one is more right than the other. But that's this is kind of like basic separation of variables. So we'll go to a little bit harder one. And honestly, it wouldn't be a bad idea if you guys paused the video and tried to see if you could figure out this one on your own first. Okay, now if you've unpaused it, I guess what I'm looking at, to me, the hardest part that most students have is trying to figure out which side should be x's and which side should be y's, because looking at this problem, they're kind of all over the place. And what I specifically look for when I'm trying to set up a separation of variable problem is I specifically look for the dy and the dx. So I'll erase this next part in a second. if you're integrating anything, doesn't matter what you're integrating, the dx or dy is right there at the end being multiplied. There's no situation that we've ever had that a dx, it would be divided on the bottom, or a dy. I mean, it doesn't matter what variable. So if our goal is to solve these differential equations by integrating, then I know dx or dy would have to be multiplied kind of on the top of a fraction. So if I'm looking at this original problem that we got, I definitely focus on the dy and dx. Those are already being multiplied, and if I would move either one of these, it would become divided. So I'm going to leave dy there and dx there, and that essentially is what I'm using as kind of my cornerstones for deciding which side is x and which side is y. So I need to divide both sides by x squared plus 4. And then if I look on the other side, I need to divide both sides by y. I'm going to leave that x there. And then that way I would rearrange everything. The left-hand side would become dy divided by y. The right-hand side would become x divided by x squared plus 4 dx. It doesn't matter if you write it on top or out front, it's just kind of whatever you're comfortable with. But either way, I've got all of my variables grouped together. And then to solve it, integrate both sides. Okay, integrating derivative of original, you should be somewhat comfortable with this form, seeing it frequently. This is going to become natural log. And then this one actually is similar, it's awfully close. Depending on what style of integration you used, I know everybody does it slightly different. The top isn't quite the derivative of the bottom. The top would have to be 2x to be the derivative of the bottom. So I'm going to put a 1/2 up front. So then this side, when I integrate it, would become 1/2 natural log, because I've got derivative of original, natural log of the bottom. And then plus c. Now, this is theoretically a general solution. Unfortunately for you, you're never going to see this answer anywhere like in a textbook or Slater or anything like that. So, but this is a general solution. It's just, it actually can be solved further. So one thing that we can definitely do is this absolute value symbol right here, we could get rid of. And the main reason we could is because x squared plus 4 could never be negative. So the absolute value symbol isn't even needed. Also, we've got a 1/2 multiplier in the front. So that could be brought inside as natural log of x squared plus 4 to the 1/2 power, or square root. And then the next bit of trickery, or magic, whatever you want to call it, you know, we're basically magicians, is C is kind of something that can be manipulated a lot, to be honest. It's a number that you're going to find later, so what I'm actually going to do is I'm going to manipulate it, and I'm going to write it as ln of C, because it would still be something I find later. And the only reason I would want to do this is I can combine these two natural logs together. And I could write this as natural log of C times square root of x squared plus 4. And then by doing that, we can take off the natural logs because the insides are the same. So absolute value of y would be absolute value of y would be C times square root of x squared plus 4. And then if I want to remove the absolute value on the y, this is kind of like the shady area I was talking about at the beginning. It's not always clear because there's no clear-cut rules. If I take off absolute value, it would have to be a plus or minus. But a plus or minus on a C it gets absorbed into it because it's just like a multiplier. So you actually can sort of solve this one for y. And then this would be the general solution that you would see in textbooks and answer keys and multiple choice problems. Although, like I will point out, like I said earlier, this 100% is also called a general solution. It's just not simplified down. Okay, last example. And the only reason I'm even doing another example is because this one feels very different, even though it's the same kind of question. So it says find the equation of the curve that passes through the point 1, 3 and has a slope of y over x squared at any point xy. Nowhere in there does it really feel like it directly tells you how to solve this. And I get how, as a student you want to look for that, but so find the equation of the curve. That's actually telling us to find a particular solution, because it's saying find the equation of the curve that passes through 1, 3. The equation of the curve would have been a general solution, but the fact that it was saying passes through the point 1, 3 would be a particular solution. And even more key, when it tells you the slope is y over x squared at any point xy, that's directly telling you that dy dx, the slope, is y over x squared. And I'm going to solve this by integrating, but first I need to rearrange it to make sure the variables are lined up correct. And this is what I was talking about before when I focus on the dy and the dx. This dy is being multiplied on the top, and so then to me this one should stay right there, and that's this left-hand side is going to be y's. This dx is currently being divided, and I know I can't have that. So I need to multiply both sides by dx to make sure that the dy and the dx are in the correct locations. And then over here, the y over x squared, well, x squared is supposed to be on the right, so I'll leave it on the right. And then I need to divide both sides by y to move it to the left. And then these would be rearranged correctly. And let me scroll down a little bit here. So I'm going to integrate to find the general solution. So I would have natural log of y, and then 1 over x squared, I wouldn't write it as 1 over x squared, I would treat it as x to the negative 2. So if I integrate that, I get x to the negative 1 divided by negative 1 plus c. And I'm going to go through and actually solve for y just to make it look nicer again. So this is log base e. So if I solve for the inside of the log, it would be e to this power. And again, this is the same sort of trickery we did before. I believe it was on yesterday's video. Yeah, when we first were learning exponential. So I'm actually going to treat this and write this. Instead of writing plus c, I'm going to say times e to the c, which is backwards for how we usually do it. E to the c is just a c. So I've got c e to the negative x to the negative 1. And then if I want to solve for y, the plus or minus would go onto the c and be absorbed into the c. So this is my general solution right here. And we were given the point 1, 3. We were told the general solution that goes through the point 1, 3. So then I want to find the particular solution that goes through that point. So I'm going to say 3 equals c e to the negative 1 to the negative 1, which is negative 1. And if I'm solving for c, I need to multiply both sides by e, because this actually says c divided by e to the first. So 3e is c. And let me write my particular solution, because I have a feeling I got to work with it a little bit. So y equals 3e, because that's c, times e to the negative x to the negative 1. And whether it's obvious or not to you right now, this actually says e to the first times e to the negative x to the negative 1. So I can put those together. Because they're like bases, I can add their powers. So I'm going to have e to the negative x to the negative 1 plus 1. And then that would be my particular solution that went through the point 1, 3. Hope that helps.